Hello students, from today we start to solve the IB Math A AGL May 2023 paper 3 time zone 2 past paper. Today we'll be solving the question number 1 of this paper. You will be getting the links to all the previously solved questions of the other past papers in form of playlists in my channel NS Online Math Tutoring Classes. I'm Nilanjana Sanyal. I am an online IB Math A AGL level tutor. In case you want to join my classes, please contact me for more details. My phone number is given below at the bottom of the screen. So without any further delay, let us start answering the question number 1. The maximum mark is 24. This question asks you to examine the number and the nature of intersection points of the graph of y equal to log of x to the base a, where a belongs to the set of positive real numbers, a is not equal to 1. And the line y equal to x for particular sets of values of a. In this question, you may either use the change of logarithm base formula, that is log of x to the base a is equal to ln of x, that means to the base e, over ln of a, or a graphic display calculator logarithm to any base feature. The function f is defined by f of x equal to log of x to the base a, where x belongs to the set of positive real numbers, a belongs to the set of positive real numbers, and a is not equal to 1. Subpart A's question is consider the cases a equal to 2 and a equal to 10. On the same set of axes, sketch the following three graphs: y equal to log of x to the base 2, y equal to log of x to the base 10, and y equal to x. Clearly label each graph with its equation and state the value of any non-zero x-axis intercepts. It is containing 4 marks. And since it is a paper 3 question, of course, we can use the calculator, and we will be using, at least I will be using the T-square CX2 calculator. Okay. So I need the graph page. I have to go to the graph page. And first graph, let us draw log of x to the base 2. So I have to take log of base is 2 and it is x over here. Okay, and enter. This is the log of x to the base 2 graph. And I come to the second graph. It is log base 10. Actually, you may write the 10 explicitly, the base 10, or else even if you don't write, the calculator will be taking the base as 10 in case you don't write the base explicitly. Okay, and this is the log of x, or log of x to the base 10, and I can have the y equal to x, y equal to x. Okay, now let me just change the window settings. I'm taking this as -1 and keeping the x max as 10. This is fine. Okay, so I can just bring this down. Okay, and I know the red colored is the log of x to the base 10, the blue colored is log of x to the base 2, and the y equal to x is the black line. So we need the, we are seeing the y equals x line is passing through the origin, and we are seeing these two curves, the logarithmic graphs, these two are passing through the same point at the x-intercept. We should be knowing the value of this point, the x-coordinate of this point, but anyway, let us just find it. In case you do not know which graph, let me take this graph. Both the graphs will be having the same x-intercept. It is 1, 0. Has to be because log of 1 is equal to 0. Doesn't matter which base it is. So these are the three graphs that I have drawn. This is the answer that you have to give. In parts B and C, consider the case where A is equal to E. Note that ln of x is log of x to the base of E. Subpart B's question is use calculus to find the minimum value of the expression x minus ln of x, because we may definitely graph this expression and we can find the minimum value, but they are asking us to use the calculus, not the graph, justifying that this value is a minimum and it is containing 5 marks. Okay, so subpart B. y is equal to x minus ln of x. So dy by dx is equal to 1 minus derivative of ln of x with respect to x is 1 over x. Okay. And for the minimum point, obviously, dy by dx value has to be equal to 0. Okay. So 1 over x is equal to 1 or x equal to 1. And now we have to prove that it is a minimum point. It is a stationary point, no doubt, but whether it is a maximum or a minimum, we have to find that. Okay. So for that, we can either draw the sign diagram or we can get the second derivatives expression. I am getting the second derivatives expression. So d2y by dx square is equal to 1 minus 1 over x. The derivative of 1, it is a constant term, it is equal to 0. And negative 1 over x, 1 over x is x to the power of negative 1. So it is negative times negative 1 and x to the power of negative 2. So this is equal to 1 over x square. Okay. And when x equal to 1, d2y by dx square, when x equal to 1, is equal to 1 over 1 square, which is equal to 1, which is greater than 0. Therefore, the x value to find the minimum value of the expression. So it will be the minimum value therefore this is minimum. Okay. When x equal to 1. Minimum value of x minus ln of x is equal to 1 minus ln of 1. Ln of 1 is equal to 0. So this is equal to 1 minus 0 is equal to 1. Okay. Therefore, the coordinates of the minimum point, although it is not asked, you may write it, or the minimum point of the minimum point is 1 comma 1. Okay. X equal to 1 and this is the y's expression x minus ln of x. This is also equal to 1. So the coordinates of the minimum point has to be 1 comma 1. So we have given the answer and we have got 5 marks. Okay. Use calculus to find the minimum value of this expression. Justifying that this value is a minimum, we have justified that using the second derivative. Subpart C. Hence deduce that x is greater than ln of x. Okay. So let me write the subpart C's answer over here. X is greater than ln of x. Since the minimum value of y in the graph of x minus ln of x is 1. Therefore, x minus ln of x is of course greater than or equal to 1, but I need the 0, so I can write greater than 0. Okay, x minus ln of x is greater than or equal to 1. But since I have to prove this, I am taking x minus ln of x is greater than 0. Okay, so therefore, x is greater than ln of x. So this is deduced. Okay. Subpart D. There exist values of a for which the graph of y equal to log of x to the base a and the line y equal to x do have intersection points, because in subpart A we have seen the y equal to x line and the graphs of log of x to the base 2 or the log of x to the base 10. They did not have any intersection points. So, but they are saying that for some values of E, they do have intersection points. And the following table gives three intervals for the value of E. The intervals are E is greater than 0 but is less than 1, because E cannot be, E is the base of a logarithmic function. E cannot have the value of 0, E cannot have the value of 1. So the first interval is E is greater than 0 but is less than 1. Second interval is E is greater than 1 but is less than 1.4, and the third one is E is greater than 1.5 but is less than 2. And the number of intersection points are given as P, Q, and R. We have to find the values of P, Q, and R. By investigating the graph of y equal to log of x to the base e for different values of e, write down the values of P, Q, and R, and it is containing 4 marks. Obviously, 3 marks are for the 3 variables, but don't think that you have to write some lines to get the extra 1 mark. The extra 1 mark is for knowing how to find these values. Okay. So you have to just give the answers, the values of these 3 variables. And of course, we have to use the calculator. And it is the graph. First of all, let me draw the easier one, the y equals x line. Okay. And then I have to draw the logarithmic curve. So it is okay. And it is A. Yeah, you see, first time it gives me a warning, because you could actually, I'll be using the slider. Okay, you can first of all create a slider by going to the menu and then actions, and let me just show you. If you come to this actions, you go down and you can create this insert slider. I'm not doing that. I'm writing the A over here. First time it did not allow me, but next time it has allowed me, and it is taking this expression, but it is saying, do you want to create a slider for A? Yes, I do. So this is the slider, and you are seeing that the present value of E is 1, and the minimum value of A will be -5, and the maximum value of A will be +5. But I need the A values from 0 to 2. I don't need from -5 to +5. And also, if you don't change the increment size, it will be going in steps of +1. Okay. So we have to change all these. Therefore, we have to press Control and Menu. And you see, it is the settings. You have to click on the settings. The first value is, we start from 0, that is the interval range, and I'm taking the present value of A as 0. Variable is A, that is fine. And the present value of A is 0, I'm taking. So it is 0. And minimum value is also 0. And the maximum value should be equal to 2, because I'm having 2 as the maximum limit. And step size, over here you have to write, enter a value. You can write it, you see 1 to 1.4, 1.5 to 2. You can take step size of 0.1, or you can take step size of 0.05, up to you. I'm taking 0.1 and okay. Okay, now you see the minimum value is 0, the maximum value is 2, and the present value of E is 0. Okay, and now what do I do? I just, and you see, you cannot see any logarithmic graph, because of course you cannot see, because the base, we have defined it as 0. That's why you're not having any graph. But what happens if I click on this and see, now it is just, it has gone to the maximum. Let me just bring it to the minimum thing. Okay. Fine. And in case it goes to the extreme, you just bring it to the minimum and you start again. Now you see the x value is 0.1, and you are having this graph. You are having this graph, and I can change the settings also, because I don't need the negative side of the x-axis. So let me change the window settings. I can take this as -1, and x max, let it stay as it is, and y min, it can stay, and y max, I'm not sure about what is the maximum value that I'll be needing, but in any case, or what is the minimum value that I'll be needing. I'm not at all aware of these values, but I'm taking the y max as 20 and I'm keeping the y min as it is. And okay. Okay. So you see, there is one point of intersection when e is equal to uh, negative 0.1. Okay. When e is equal to 0.1. And okay, so you see, there's one point of intersection and I am just going on. Up to 1, I have to take. It is continuing to have one point of intersection. This is e equal to 1. At e equal to 1, of course, you will not be having the graph because you cannot have the base as 1. Okay. But no problem. I'm just increasing. So we have seen that uh, between 0 and 1, there is one point of intersection. Okay. And from more than 1 to 1.4, I'm still seeing there is one point of intersection, but I'm not sure. But let me just change the Windows settings once more. Let me just take the X value. X min is fine, but let me take the X max as 30. Okay. Okay. X max as 30. Even now, it's not showing. So I have to change the Y value also. See, if you don't have any idea, then you have to do this repeatedly, or else you can take a large value, 50 or something. Okay. Let me see 35. I'm not sure whether it will work or not. Okay. Even now it's not working. So let's now let me take it as this as 50 and that also as 50. Okay, now it's fine. Now it's fine. You see, for e equal to 1.1, you are having two values of 2 points of intersection. Okay, it makes sense. Between 0 and 1, you are having a single value of single point of intersection. Between 1 to 1.4, let us see whether the 1.2, it's still, why does it go so fast? For 1.4 also, we know that it is below 1.4. If I just take 1.3, you can distinctly see there are 2 points of intersection. Even for 1.4, if I just change the Windows settings a little and I make X max as maybe 20, let's see. I think you're still having 2 points of intersection. What happens if it is 10? If the thing is 10, this is 10. Yeah, and this is also, I can take this as maybe 30. I see. Yes, it is intersecting. It is intersecting. Even if I can go on just changing the settings, and now maybe I can take this as 15. Let's see. Yeah, you are having two intersection points when e equal to 1.4. Okay, so for the middle interval, you have the value of q should be equal to 2. And what about the last interval from 1.5 to 2? And you see, when you go to, there's no intersection point when it is 1.5. Even over here, you see the two graphs, the line and the curve, they are not meeting. So when and they are saying e is greater than 1.5, definitely it will not match, not meet. Okay, I have taken the step size as 0.1. If I had taken the step size as 0.05, you would have seen this better. But anyway, you can see these two are not touching anywhere. So from 1.5 to 0, as I just increase the a value, the curve is coming down, so there's no point of intersection. So P is equal to 1, Q is equal to 2, and R is equal to 0. Okay, so let me write this as 1, this as 2, and this is equal to 0. Okay, so these are the values. In parts E and F, consider A belonging to the set of positive real numbers and A is not equal to 1. For A greater than or equal to 1.4 but is less than or equal to 1.5, over here they did not include the equal to sign, but in this case they have included the equal to sign. A value of E exists such that the line y equal to x is a tangent to the graph of y equal to log of x to the base A at a point P. Sapati's question is find the exact coordinates of P and the exact value of A, and it is containing 8 marks. Okay, so you can use the slider and change the value of A, but you will not be getting the exact value. What will be you be taking as a step size? You can take 0.01. You can again take 0.001. What will you be taking? So you will not be getting the exact value of A by using that slider. So we have to get the exact value of A and the exact coordinates of P manually, and that is why this subpart is containing 8 marks. Okay. So let me start my answer for subpart E over here, and I can write that. So and it has to be because when E is greater than 1 but is less than 1.4, there are two intersection points we are seeing. And when E is greater than 1.5 and less than 2, they don't have any intersection point. And I can go to the go over here. You see, I can bring up. See, as I am decreasing the A value, now it is having two intersection points. The present value of E is 1.2, and as I am just going on increasing the A value, the curve is coming down. Okay, so even for 1.5, you see these two curves are slightly, the line and the curve, they are not meeting. There is a slight gap between them. And as I increase the A value, the curve is just coming down. So there should be a value of A where the line and the curve, they just touch each other at a point. So that is when the line becomes the tangent of the curve. And we have to find the A value for that point and the coordinates of that point. So for y equal to x, m is equal to, m is the gradient, m is equal to 1. Okay. And what is the gradient of the curve? So d dx of log x to the base a should be equal to 1 because at point A. Sorry, not point A, but point P. Okay. So now, in case you cannot differentiate, you can, of course, change the base, and they have given the change of base formula right at the beginning of this question. So it is, if you know how to differentiate in one step, you can do it, or else you change the base, and it will be ln of x over ln of a is equal to 1. And ln of a is in the denominator. It is just a number. Don't apply the quotient rule, okay? Because ln of a is just a number and it is in the denominator. So I can just write this as d dx of 1 over ln of a times ln of x is equal to 1. Okay, and now you see 1 over ln of a is nothing but the coefficient. So I can take this out. 1 over ln of a and times d dx of ln of x is equal to 1. And now we know the derivative of ln of x with respect to x. So it is 1 over ln of a times 1 over x is equal to 1, or x is equal to 1 over ln of a. Okay. And now at the point of the meeting of the two graphs, the y coordinates should be the same. So y equal to log of x to the base e, and this is the curve's expression, and y equal to x is the line's expression. So this should be equal to x at point P. Okay, so this is the expression, and we will be substituting this value of x. So log of to the base e, of course, and this is 1 over ln of a is equal to 1 over ln of e. Okay, and since I am having ln of a and this is log to the base a, therefore let us come just change this base to ln again. Okay, this is having the base of a, so let us change this to base e, and this becomes then ln of 1 over ln of a over ln of a equal to 1 over ln of a. So that I can cancel the ln of a's from the both the sides, and I get ln, and 1 over ln of a can be written as ln of a raised to the power of negative 1. So I am writing ln of a raised to the power of negative 1 is equal to 1. Okay, and so this is equal to negative ln of a is equal to 1, or ln of a. Don't get confused, and don't think that whatever you are writing is wrong. How can you have ln of a? Surely you can have that. Just remember, check your working and be sure that what you are writing is correct. You haven't made any silly mistake. That is all that you have to be sure of. Okay, this expression, however weird it may appear to be, it is correct. Okay, so now I have to get the expression for e. So what can I do? I can just take the exponential e to the power of. So this gives us ln of a as e to the power of negative 1. Okay. And again, I have to, since I have to get the value of a, again, I will be taking the exponential. So this is equal to e to the power of negative 1. And e to the power of negative 1, you can keep it in this way, or you can write this as e equal to e to the power of 1 over e, because e to the power of negative 1 is 1 over e. So this is the exact value of e. This is the exact value of e. Okay. And then we have to get the exact coordinates of p. So first of all, let us get the x coordinate. X coordinate of p is equal to the y coordinate of p, because the p point is on the y equal to x line. So the x coordinate has to be equal to the y coordinate. So y coordinate, sorry, is equal to, x was equal to 1 over ln of e to the power of 1 over e is equal to 1 over, I can take this power down, it is 1 over e times ln of e, and ln of e is equal to 1. So this is 1 over e, which is equal to e. Okay, therefore I'm writing it over here. I'm not having much space below, and I have to answer this part f. So I'm writing the answer over here. P is having the x coordinate as e and the y coordinate as e. So this is the answer for the subpart E. Subpart F. Write down the exact set of values for A such that the graphs of y equal to log of x to the base A and y equal to x have, the first subpart I says, two intersection points. Okay. So I am writing my answer over here. For A is greater than 1 but less than 1.4, we had two intersection points. Since y equal to x is a tangent to the curve, this is the I's answer, to the curve at E, E comma E, for A is equal to e to the power of 1 over E. Therefore, A values between this and less than e to the power of 1 over E should have two intersection points. Okay, because at when E equal to e to the power of 1 over E, then you are having a single meeting point. The curve is a tangent. Therefore, and we have seen that as we are increasing the A value, the number of the curve is coming down. So at A equal to e to the power of 1 over E, it is having a single intersection point. So if you just increase the value of A, it will not be having any more intersection points. Okay. So this is the answer for the subpart I. And it is containing just a single mark. So I have written few lines. So you can just give the answer also. That will be sufficient. Don't have to explain. Though I have explained it. And for the I'm just writing the answer. For it will be the A values will be A is greater than e to the power of 1 over E. Because if you increase the value of A, the curve will be coming down. When A equal to e to the power of 1 over E, it is just having a single meeting point. If you make the A value more than e to the power of 1 over E, it will be coming down and there will be no intersection point. Okay. So no intersection points. So we have completed answering this question. Oh, I had some more space remaining. I did not see. I could have started this one line or two line below. But anyway, we have completed answering this question number 1. Thank you for staying with me till the end. In case you're liking my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my videos. And in case you have not subscribed to my channel, please subscribe to my channel. It will be motivating me to make more math videos for you, as well as it will be telling the YouTube that my videos are worth watching. So it will be showing my videos to more number of students. So indirectly, you will be helping other students. And we meet again very soon in our next session. We'll be solving the question number 2 of the same paper. Till then, bye.